Since the birth of the First World War, securing air superiority has been of utmost importance for any military to achieve dominance and victory. Speed, maneuverability, and firepower were the three keystones in securing air superiority. During the World Wars, the radical and incremental innovation within the fighter engines allowed fighter planes to achieve greater speed and efficiency throughout history. The first S-curve of the fighter aircraft engine was the different variations of the piston engine. In the pre-Wright brothers era, the steam-powered piston engine was the first aircraft engine created. From its first invention in the 1870s by Watts, the steam-powered engine went through multiple iterations and incremental changes. Many engineers and designers like Langley, Ader, and Maxim used steam-powered in their early design, but were unsuccessful in taking flight or being able to carry an individual, due to the inability to produce enough propulsion or thrust. With a high enough power-to-weight ratio, the steam-powered was not practical. The first major incremental and discontinuous innovation was when the Wright brothers took flight in Kitty Hawk, North Carolina in 1903. The innovative engine that enabled them to be the first successful manned flight was the four-cylinder inline gas-powered piston engine. The piston engine was more superior and advantageous than the pre-Wright brothers steam-powered piston engine. Thus, this innovation was dominant in design and steam-powered was discontinued. The piston draws a mixture of fuel and air into the cylinder. As the intake valve closes, the piston compresses the fuel-air mixture. A spark plug within the cylinder ignites the fuel-air mixture, creating a combustion, and the expanding gas pushes the piston down, thus allowing the piston to expel the gas from the cylinder through the open exhaust valve. After the four-cylinder inline engine, the rotary gas-powered piston engine was the first type of gas-powered engine commonly used in the World War I. Planes like the Sopwith Camel and the Fokker DRI used this type of engine, but this type utilized a tremendous amount of fuel and was difficult to maintain. The radial gas-powered piston engine was the incremental change that replaced the rotary engine and was used in every airplane engine after 1918. The gas-powered piston engine was utilized throughout much of World War I, but began to be phased out due to the constraints on the engine, such as flying efficiently at higher altitude and at a faster speed.
World War II saw a significant spur in fighter aircraft innovation. The jets of World War II inaugurated the first generation of jet fighters, in which turbojet propulsion was applied to existing airframe technology and aerodynamics. During this period, demand for speed and agility increased as each side tried to gain air superiority. This saw a movement away from the piston engine, which was too heavy and had a tendency of shaking the aircraft at higher speeds, introducing us into a second S-curve. A radical change advanced the combat and shortcomings of the piston engine. The Heer 178 was the first jet-powered aircraft that flew on August 27, 1937. The aircraft was powered by a revolutionary axial flow turbojet, one in which the air flows straight through the center of the engine. A competing aircraft was introduced in 1941, the Gloster E-2939, which was powered by a jet engine that used centrifugal flow, in which the air was thrown radically outward during compression. During the war, the axial flow turbojet had an upper-hand over the centrifugal flow, which resulted in it being the dominant design and most widely produced jet engine. Air is drawn into the rotating compressor through the intake. It is compressed to tremendous pressure before entering the combustion chamber. Fuel is then mixed with the compressed air and burns into the combustor. The combustion products then leave the combustor and expand through the turbine, where power is extracted to drive the compressor. The turbine exit gases contain considerable energy that is converted in the propelling nozzle to a high-speed jet. By replacing the propeller used on piston engines, higher aircraft speed becomes attainable. In second-generation fighters, incremental improvements came about to the turbojets. The introduction of the afterburn or reheat meant that turbojets became more powerful. This permitted large temporary thrust increase by the spraying of fuel into hot exhaust gases and the tailpipes, in effect turning the turbojet into a ramjet. Think about a nuclear missile. These were great for sonic flight but highly inefficient in subsonic flight. Third-generation fighters saw another incremental improvement with moving away from turbojets to turbofans. Turbofans were invented to circumvent the undesirable characteristics of turbojets being insufficient for subsonic flight. A turbofan can be thought of as a turbojet, being used to drive a duct fan, with both of these contributing to thrust, whereas all the air taken in by turbojet passes through the turbine. In a turbofan, some of that air bypasses the turbine. From the 1980s until present, jet engines have seen incremental innovations with the aim to make them more efficient, and new technology from other industries have also been implemented to make it lighter, low cost, involve less moving parts, and increase power. Some of these improvements include the capabilities of subsonic flight without the afterburners and the ability for a jet to lift vertically. The continued search for new sources of power to propel future fighters goes on. While engineers continue with incremental changes to the turbofan engines, others have started to look for the coveted power in other places. A few select have started to experiment with rocket-powered engines like the scramjet. These engines have no moving parts. Combustion takes place as air moves supersonically through the engine. The high pressure is produced by ramming external air into the combustor using the forward speed of the vehicle. The external air that is brought into the propulsion system becomes the working fluid, much like a turbojet engine. The idea of a scramjet first appeared on the drawing board in the early 1900s, as engineers continued to experiment on rocket-powered engines. This long-forgotten idea could be powering the next generation of fighters in an effort to break into the next realm of hypersonic speed.